Hi, this is a video for COMP345. This is for slide set number 4, second part. This is for slides 23 to 47. This is for week 3. In this lecture, we're going to talk about the static specifier, the friends of a class, and the constructor and destructor. Go to the slides here. Oops. Okay, so for static, well, I'm sure you have seen that in Java, where you can declare static members. There's also, so yes, that applies to classes, but also that applies to other things, such as variables that are declared outside of a class. So static is a little bit, static has different meanings, though it really has the same inherent meaning. But depending on what you apply it to, it has a slightly different meaning. That's one of the things that's confusing about static. It can have different meanings depending on where you use it. So for static members, so when you declare members, data members or member functions, you can declare them as static. So that will be exactly the same thing as what you have in Java. So what that means is that you have your member of the class belongs to the entire class, or it's a member that is shared across all the objects of a class. Now, the difference between how you call a static member or member function, or how you refer to a static data member is that you have to call it on the class rather than call it from an object. So you use the class name rather than referring to an object's name. Same thing as for what you have in Java when you have your static members of a class. So if it is a data member, then what that means is that this data member is unique across all the classes. In technical terms, what that means is that actually this static member you define for a class is a variable or memory space that is in the global scope, meaning that when you store the values of your static members, they are declared somehow in the same block as the global variables. And any object that share this static variable actually share the same space to store the value of this variable. So in a sense, a static class member or data member is some kind of global variable that is accessible only to the objects that belong to this class. Another thing is that, exactly like in Java also, if a member function is declared static, can only use other members that are also declared static. Why? Because you can actually call your static member function on the class without having an object having already been declared. So that means that if you call such a function that does not belong to any object, then it must only refer to static data members and other static member functions. So there's kind of a chain here. If you declare something static, it can only use other things which are static. So it has a tendency of, spreading the staticness of some members inside of your class. So that's basically used to define state and behavior that is independent of any particular object's state. So basically you want to share a common state between all the instance objects of this class. So how do you initialize them? Generally speaking, you would be initializing them outside of the class declaration. We will see an example of that in the next slide. If you want to initialize them inside of the class definition or class declaration, then it must be a constant expression. Initialized with a constant expression. There's also even more restrictions to that, as I will say here. So here I'm basically having a very simple ID generator class. It declares this ID here, which is a static int. And then basically what it does is that when you get the next ID, it returns the current ID and then increments the ID inside of the object. And all of this can be used without declaring any object, because both of my members are static members. So it doesn't make sense to actually have objects of this kind, though you could, but normally you would use this class as static class, even though in Java, in C++, in other languages, you have this notion of, you have the possibility of having this notion of static class, but in C++, there's no such thing. Okay. If you would know what is a static class in another programming language, then that's a good example of a static class, but in C++, you don't declare a class as being static. In other programming languages, you can have a static class, which means that it's a class that's composed only of static members. Now here, how do I initialize this int here? That is my private static member of this class. I essentially initialize it here outside of the class declaration in the global scope. You see, that's another hint that a static a class member, a data member, is in fact some kind of global variable. And then when I use it, for example, I can have a for loop here that's gonna get the next ID five times. So it's gonna output 1, 2, 3, 4, 5. Okay. So note here that I've never created any instance of this class. So I'm just basically using the class itself and calling this static member function, which then uses and increments this static data member here. Now, if you have some static members, which ones can you initialize inside of the class declaration? This is an issue that varies a lot across different standards, C++ standards that you may have. You might say the most commonly understood restriction is that if you want, the only things for which you're allowed to initialize or data members that you're allowed to initialize inside of a class declaration would be an integer, which is a constant, and static. Okay. Normally, you should not be allowed to initialize a value like this at the variable or data member declaration level. But you have to understand this varies widely across different standards. Okay, so that was for member variables or data members of a class, but you can also declare other things which are not a data member as static or member function. So you can declare variables inside of a function as static. So when you declare a variable or a function at file scope, the static keyword specifies the variable function has internal linkage. So you basically cannot refer to it outside of the current compilation unit. So essentially, when you declare, for example, a global variable and you declare it as static inside of a compilation unit, that declares a global variable, but only for the scope of this current compilation unit. You cannot refer to it from the exterior using extern from the exterior, as we briefly saw before. There are some programming examples about that in the lab if you want to look at that. So if you declare a global variable and then you declare it as static, then it is, yes, a global variable, but it only has internal linkage for the current compilation unit. So you see that's a quite different concept, but still, it still refers to this notion of a global variable. It's a little bit far-fetched to say that a static member of a class is some kind of global variable, but in fact, technically speaking, that's what it is. So when you declare a local variable, meaning a variable that is declared inside of a function body, if you declare it as static, then that means that this variable inside of the function has what is called static duration. So essentially what that means is that you're creating a variable inside of your function that will retain its value across different calls to this function. So again, that comes back to the same kind of concept. Technically speaking, in terms of implementation of how it's happening at runtime, this variable is some kind, again, of global variable that stays in the memory until the end of the execution of the program. Okay, that's how this variable is keeping its value independently of whether the function is executing or not. Okay. So that allows you to create a variable inside of a function and then have a certain value that will be kept even after the function has returned. Normally, all the variables that you have inside of a function, they are stored, their value is stored on the stack. And then when the stack frame is popped, then all these values that disappear. However, if you declare some values, variables inside of your function as static, they are actually stored in the global variables stack frame at the bottom of this of the stack. So these variables have what is called static duration, meaning that they will retain their value from the beginning until the end of the program's execution. Of course, if you use too many of these such variables, then that has a tendency of having your program consume more memory than if you would not have such static variables, static local variables. So all static variables persist from the start of execution until the program terminates. The same thing is for your static data members. Okay, so you see that it's the same concept here. It's a value that is kept from the start of the execution until the end of the execution, and that is shared. If it is a static data member, then this value is shared across all the objects of this class. And if it is a static variable defined inside of a function, then this value is shared across different executions of this function in which this static variable is residing. So you see here that I can be having a static global variable. Again, repeat, that means that this is a global variable that is whose linkage is local. So that means these are two global variables inside of the current compilation unit. This is a true global variable that can be accessed from another compilation unit using extern. However, this B here cannot be referred to outside of this compilation unit. If I have static inside of a function, that actually means that this variable here will retain its value across different executions of the function f. This variable, of course, should be initialized. Then this initialization would apply only at the first time that you actually call this function f. Okay. So I'm not going to go over this sum up here. I suppose that you will review that by yourself. Now, next thing is, it's a little bit going in different directions here, but the next thing I have is friends. So you can declare friends of a class. Now, what does that mean? So when you have private and protected members of a class, that is meant to hide the access or visibility of these members from outside of this class, meaning that only the code in the functions of this class, of the member functions of this class, can access by name these members that are private or protected. So that's the concept of having private and protected to limit access. Now, friends is actually about erasing this limit. Okay, so it's a little bit controversial because it's a contradiction. If you are to define private and protected, then there's a design reason why you might want that. Then you create this other notion, which is a friend, that kind of erases these protections, okay, or limitations. So that's essentially what is friend. You allow an external entity to actually override the private or protected nature of some of the members of the class. Okay. So when you declare, for example, a class as a friend of another class, then the code inside of this other class here can actually refer to the members of the class which are private. We'll see some examples later. How do you declare friends? So a friend can be a friend function or a friend method or a friend class. So if you want to declare a friend is a friend of a class. If you want to declare a friend of a class, then you basically provide a declaration inside of the class that wants to declare that another thing is a friend of it. You must have a friend declaration inside of this class saying, this other thing here is a friend of mine, and I allow this other thing to override my private and protected specifiers. Basically allow another entity to access freely as if they were inside of the class. So important to realize that friends are not members. So yes, you declare a friend inside of a class, but the friends of a class are not inherited by the subclasses of a class. So friends are not inherited. So yes, this is what you can call a rogue feature. It's, you define very nice structured concepts such as private and protected. Friends is essentially there to override these notions. Okay, let's quickly see some examples here. Here I have a C rectangle class. And then what I want to do is to have a free function. So you see this is a free function because it does not belong to any class. So it's a free function called duplicate that receives a rectangle and then outputs a rectangle. Okay, so it's not a member of the class rectangle. Okay. The idea here is that the rectangle has a width and height, which are private. Okay. So if I want to call duplicate here to create a copy of this rectangle, then this function here needs to have access to width and height of the rectangle that it receives as a parameter. Now, because it's not a member of the class and because width and height are private members, then it should not be able to do that. If you would compile this code as is here, compiler would say that width and height are not visible in this scope. Now, if you want to override this and allow duplicate to work, even though it does not have private access to the private members of this class, then you can declare this function duplicate, this free function duplicate, as a friend of this class here. So you see that here I have, it's kind of like a member that I'm declaring, but it's not a member, it's a friend, okay? If that would be a member, that would mean that it would be inherited, but it's just a friend declaration, which is not inherited if CRectangle would have subclasses. So this essentially allows the duplicate function to be able to use the private or protected members of the CRectangle class. So that's for a friend-free function. Okay. Now, what if you want to have a friend class? So let's say I would have a rectangle class that has width and height, and that has a function area that returns width times height. And then I want to have, I have a function convert that converts a square into a rectangle. So I have my convert function here that is essentially taking the side member of a square that is passed to it and assigning it to width and height of the current object, which is a rectangle. Now, again, it's the same concept here. The side member of square is private. And there's no inheritance between rectangle and square. Okay, maybe it should, but in the example, it does not. So this is not allowed. So convert should not be able to access the side member of the square, which it receives as a parameter. Now, if I want to override this, then I can basically declare the class rectangle as a friend of the class square. So that's essentially saying that in the code of the class rectangle, in any of its member functions, it can actually access the private or protected members, in this case, side. So that makes the convert function able to access it, and thus it will then work. So essentially what that means is that when you declare a friend class, you are given all its member functions, you're somehow declaring all its member functions as a friend of this class. So that leads me to say that you can actually declare one specific member function of a class as a friend, not declare all the class as a friend, but only one or some specific function, member functions of a class as a friend. So as you may see here, I have the A object, or the A class, has a show member function, which is basically receiving an A and a B as parameters. And what it wants to do is to output the value of A for A and the value of B for the B object. However, as we see here, B in the B class is private. So when this B is received here, when you execute show, B is received here, and you try to access the B element or member of the B class, but you're not allowed to do this here because B is private. Okay. So if you want to override that, then you could declare this member function show of the class A as a friend of the B class. Okay. So again, repeat, this is a way to give access to a specific member function of a class to the private and protected members of the B class in this case. I could have declared the class A also as a friend of B, but then that would open the door for all of the member functions of the class A to have access to the private and protected members of the class B. Okay, so friends, it's not something that is absolutely necessary, but it's something that can be handy. If you want to, for example, we'll see later when we present how to overload your operators, especially the stream insertion operator. If you want to declare your stream insertion operator as a free operator, then it needs to have access to the private members if there are some private members. So that's why declaring a stream insertion or extraction operator as a friend free operator is one of the most prevalent uses of friends. One thing is realize that if you overuse friends, it kind of destroys the notion of public and protected. So that creates some possibility of confusion in your design to other people or yourself after a certain time. Because sometimes you do, when you do what is called clever design, you make things which are not so easy to understand that are clever. Sometimes other people will not understand what you're trying to do. Very often also, when you create something clever and then it sits there for a few months and you come back to it after a few months, you are in the seat of somebody else because you might not be able to understand your own cleverness after some time. So if friends is one of those things that is, obfuscating possibly your design. So let's go to constructors and destructors. That's something that we will, talk about a lot of times after, but here I'm just introducing some of the aspects of it. So as any other object-oriented programming language, or almost any other object-oriented programming language, C++ relies on constructors and destructors. So basically, a constructor is a member function of a class that is called when an object is created. So that's something you have in Java, but in C++ you have a destructor, which is a member function that is called when the object is destroyed. Okay. In Java, you might say, well, there's no destructor in Java. That's not entirely true. There is a destructor, but the only thing that will ever call, you're not, well, you could, but you're not, typically calling your own destructor in your code. There is a destructor at the JVM level that is called when the garbage collector frees the memory of a certain object that is in the free store, that resides in the free store. And then the way to free this object is to call destructor. So the destructors are generated by the compiler and they are called normally only by the runtime system. So that's why you don't see them. They are there, but you don't see them. You don't explicitly call them. In C++, you have to call them yourself, especially if you are using pointers. Okay, so constructor may be called at runtime when an object is instantiated. So if you create an object, declare an object like this at runtime, the default constructor of the class day of year will be called. If you are creating a pointer to an object of this kind, then you need to call new, which is itself going to call the constructor, allocate the memory on the heap, and then make the pointer eventually point to this today object, as we saw repeatedly now before. You may have an explicit call to a constructor. Let's say this birthday here, you want to reinitialize it to another object. Then you may actually call the constructor and then assign the newly constructed object to your object birthday. Now this is how typically how the constructor would be called when you declare things or when you explicitly call a constructor or when you call the new operator. The destructor is called anytime an object is to be destroyed. So as we saw before, when is an object being destroyed? Either it's an object like this one here that is declared inside a function body, which is created on and allocated on the stack frame as this function is getting called. And then when this function is about to resolve or get out of scope, then the memory is deleted for this this object that resides on the stack frame. How this object will be freed by calling the destructor. So if a function declares a bunch of variables that are not pointers, then when you get out of scope of this function, then the destructor is going to be called for each of the objects declared in the scope of the function. Now the way to call the destructor is if you call new on an object to make it be pointed by a pointer, then the only way you can actually destroy or free this object is to call the delete operator. So new is creating a new object on the heap, and delete is to free the object from the heap. So if the objects are not pointers, then they will be residing on the stack, and then the runtime system would automatically call delete on them, or call the destructor to destroy them as the function is about to resolve. If you create pointer objects, you have to call new to create them, and then you have to call delete to free them. And when you call delete, it's going to call the destructor. Okay, so of course, as we saw before also, that you may have, if you don't do this properly, this may result in what is called memory leaks. So for example, here you enter a certain scope, and then you call new here to create this object of type foo, then this returns a pointer, this foo resides on the stack, and then the pointer my foo resides on the heap. And then when you get out of scope here, then this, as you did not call delete before you went out of scope, then my foo would be freed, but the object foo pointed by my foo is staying on the heap. And now you don't have a pointer for it, thus you cannot call delete on it anymore, so that's a memory leak. A memory leak is two conditions. You have allocated memory on the heap, and then you had a pointer pointing to it, condition number one. Condition number two is that you lose the pointer or the last thing that is pointing to this allocated memory. Thus, you don't have a pointer to point to it, so you cannot call delete on it. So it's permanently going to stay on the heap. Here, that's the proper way of doing it. Here you declare foo in the same way here, or you declare the pointer to my foo in the same way, but before going out of scope, you call delete. This is the proper way of doing it. You might declare my foo directly as an object and not a pointer, in which case this will be calling the constructor of this here, and when this goes out of scope here, then the destructor would be called on this. Okay. The difference here is that the type of this is pointer. A pointer does not have a constructor and destructor. It's just one memory cell, just like an int, for example. Okay. It's not a class, it's a pointer. Whereas this here is a class. It's an object you're creating. To create it, you call the constructor, and to delete it, you call a destructor. There's no such thing as a constructor and destructor for a pointer. That's why it cannot be automatically called. So you for the constructors, you have this notion of the default constructor. So this is exactly the same notion as what you have in Java. If you don't declare any constructor in your class, a default constructor is going to be made available. That is essentially going to reserve memory for the members of this class as well as the members of its superclasses or base classes. The proper term for upper classes to a class in C++ is base classes. Because as we will see later, in C++ you can have multiple inheritance, so it doesn't make sense to call it a superclass because you can have more than one. That's why the correct term to refer to your ancestor classes in C++ is to call them base classes. Okay, so you have default constructor, exactly the same notion as what you have in Java. So if you don't provide any constructor, compiler will provide an automatically generated one. It will do the memory allocation for your basic data members. But it will not take care of allocating memory for members that are pointers. Okay, the default constructor is not going to call new or anything like this to allocate memory to some of your members that are pointers. Again, I will repeat that very, very often. As soon as you have in your C++ classes some data members which are pointers, you start having to yourself having to define the behavior of such objects, how the memory is going to be allocated to these members and deallocated. So you cannot count on your default constructor to properly allocate memory for your objects if they contain data members which are pointers. Particularity, which also is the same in Java, if you declare at least one constructor, the default constructor is not going to be generated. I invite you to look at some of the examples there is for lab number 4. I created plenty of examples for that. Okay, so you can have as many constructors as you want, just like what you have in Java. So the difference is, so here you have 3 different constructors. Here, this is the default parameterless constructor. This is one constructor that receives 1 int, and then a constructor that receives 2 ints. So what you can have as many as you want. What differentiates them is the list of parameters that they have, the list and type of parameters that they have. So if you go and create an object of this kind here, and then name it date1, and then between the parentheses here, you provide some parameters, then the number of and type of parameters is going to determine which of the constructors to call, in which case this one here. If you call new here, oh, there's a mistake here. It should have a star here because this is, if this is assigned by, this is assigning the return value of new, which is a pointer to an object of type day of year, then day2 should be a pointer to a day of year. Okay, typo. So this uses only one parameter, so it's going to call this constructor here. Then here, the thing is that if you want to call the default constructor, you should not include the parentheses. Because if you would put parentheses here, open, close parentheses, then that will be understood by the compiler as being a inner function declaration. Okay. We didn't see that, but that's what it is. And then, of course, you can call it explicitly here, as I mentioned before. Again, the type and number of parameters would decide, allow the compiler to decide which constructor is going to be called. So this is for your header file. That will be your header file here. And then assuming that you have the corresponding CPP file or source file, then you would need to have the implementation of these constructors, which would be defined like this here. So this is a constructor because it is a member function that has the same name as the class. So again, use of the scope resolution operator. So, and one thing that you don't have in Java is what is called a constructor initialization list in C++. What that is that following the header of your constructor, you don't have to, but you can actually put a colon here and then have a comma separated list where each of the elements of the list starts with the name of one of your data members, okay, or a superclass, as we will see later, or base class, as we will see later. So in this case, for example, the meaning of that, of course, we see that the day of year class has a month and day, okay, as data members. So that's basically providing a value which is fed to the constructor. So that's basically initializing the data member month with the value of new month. That is a parameter to this constructor. And then taking new day and then initializing day with the value of new day, which is passed as to the constructor. Okay. So essentially, this is a very simple example. It's important to understand here that this other version of this same constructor is essentially doing the same here. Okay. However, there are things that you cannot call inside of the body of the function. For example, if you want to explicitly call a base class constructor, you have to call it in the initialization list, as we will see with several examples later. So initialization list is there to initialize values either by calling the base class constructor or initializing the value of the data members of the class in question. So your constructors can also optionally act as guard. What is a guard? A guard is basically something that verifies whether certain preconditions are met before you eventually proceed in a certain action. Here, the action would be that you're creating an object. So what you could do is to, inside of your constructors, put some conditions that check whether this would, the values that are passed to this constructor would result in creating a valid object. Okay. So that's what is called a part of what is called defensive programming, whereas you try to trap some invalid cases and you prevent them from happening. Okay. So your constructors can be explicitly called in your initialization list. So this is also in the initialization list. This is where also you would be calling the superclass constructor, the base class constructors. That's actually, if you want to call a base class constructor in C++, you know, in Java, you used to be able to do to call super in your constructor body implementation. In C++, you can't do that. The only way to call a base class constructor in C++ is to call it in the initialization list. Okay. If you don't call your base class constructor in the initialization list, the compiler will understand and the runtime system will understand from it that you want to call the default constructors. If you are defining your own user-defined constructors, you have to explicitly call them inside of the initialization list of your subclasses. So here, okay, so one of the things that is quite important to understand is in what order the constructors are being called. So here I created a little example here. So you have class G. Class G here inherits from class B and C, and the class B inherits from class A. Class C does not inherit from anything, and class G contains a member of type A, as well as class C contains a member of type A. Now, if I create an object of type G, then that's gonna automatically, here you see that I don't have any constructors that are explicitly declared, okay, or defined. That's basically saying that in this particular example, the default constructors are going to be used. So what is the default behavior of the default constructors? That's what I said here. So if a constructor does not explicitly call the base class constructor in the initialization list, I don't have a constructor definition, thus I don't have an initialization list. Then the base class default constructor are called, you know, in the order in which the base classes are declared. So for example, if I call the constructor, if I want to create an object of type G, then the base class constructor of the base classes, the default constructors of the base classes B and then C are going to be called. So if you want to create a G, then it's going to want to create a B. Then after a B has been created, then it will create the C. Okay. So essentially what it does is it's creating the object. My black pen. Here. So essentially, if you look in the computer's memory, when you create this, you know, I have some values here, and essentially I want to put an object of type G in the computer's memory, right? Then, as we see, there is in the G object, there's a B object and a C object, as well as an A object, okay? So there is, as part of the G, the base classes. The base classes of G are B and C. So there is essentially there's a B part of the G and there's the C part of the G. The same thing goes for B. In B, there's the base classes of B. What are the base classes of B? There is A. So the base classes of B are A and nothing else. And then C also has base classes. What are base classes of C? C does not have base classes, so this does not have base classes. Then, okay, so that's for the base classes part. G has base classes, B has an A base class, and C does not have any base class, okay? Then there is the member portion of each of these objects. For example, the object G has a part which is of type A. So that's the members. The members of G, what are they? There is only one, which is an A, okay. Now, here I would be doing the same. So as I'm creating an A here, then I might ask myself, there is the base classes and there is the members of A. as we already saw, there is no base class nor member of A. So it's just basically A is an empty object, or an object that does not consume memory. So that the only member of G is A. So the same thing I can do for the A part here. So the A part is basically does not have either base class nor members. Then B, does it have members? B does not have members. C, does it have members? Yes, C has an A member. What are the base classes of A? Nothing. What are the members of A? Nothing. And that's about it. So basically, G is composed of a B part and a C part that inherits from, as well as an A that is its enclosed members. The B part of G contains an A part, and the C part of G contains an A part. And then the A member here has no part. Okay. So when you want to determine what is the construction, or what, well, wrong term, what is the structure of a certain object, you have what are the members that are inherited through base classes, and then what are the actual members of this class. Now then the question becomes, in what order are all these parts being created? Okay, so in order to create the different parts, then the concept is that it's going to go deep inside each of the parts and then create the components of each part, and then create them kind of recursively. Okay. So what's going to happen is, if you call the constructor for G, it's going to first call constructors of its base classes. Then the constructor of G is going to call a constructor of B. Once the constructor of B is finished, then it's going to call the constructor of C. But before it's finished, it must do the same and call the constructors of its base classes, which is A. Now A would do the same and try to call the constructor of its base classes, which it does not have. Then after all the base class constructors have been called for each of these objects or parts, then it would call the constructors for each of their data members. Now A does not have any data member. So the constructor of A resolves, then it goes back to the constructor of B. It doesn't have any other base classes. It doesn't have any members, so the constructor of B resolves. Then it goes back to here, then call the constructor of C, which is trying to call the constructors of its superclasses or base classes, which it does not have. Then it will call the constructors of its data members, which is A. So the constructor of A is called. Does it have base classes? No. Does it have members? No. So constructor of A resolves. Then the constructor of C resolves. Then for G, all the base class constructors have been called. Next thing it does is call the constructors for each of its members in the order in which they are declared in the class. So essentially what it does is, as I will exemplify later, if you create a G, it essentially calls a constructor A, B, and then A, C, A, G, okay, as exemplified here, okay. I'll come back to this example later. So if you don't have any default constructor defined, this is the default behavior. Okay. If you want to define your own constructors, then you will have some freedom to actually decide what constructors are being called, but this order is, no matter if you change the order in the initialization list, it's going to be the same order as I just explained. You cannot change this order. Even though you may change the elements in the initialization list. It's always the same order, which is the order in which you declare them in the class declaration. There are also subtleties related to constructors. This is just one of them. For example, if you define a data structure or a class that has members which must be initialized. For example, a reference must be initialized because you cannot assign to it later. And a constant also must be initialized. Now, if you declare a class or structure like this and you don't declare your default constructor, then you will not have a constructor that actually initializes these values. Okay. So the default constructor does not include behavior to initialize members that must be initialized. Okay. So as the compiler will see that, it will basically create the default constructor and then declare it as deleted. Okay. There's a way that you can actually declare a constructor and then declare it as deleted. And that's what the compiler will do. The result would be that you will not have a constructor for this class. So that when you try to create an object, when you compile the code, then the compiler will generate the code and then the linker will try to find a constructor and it's not going to find it. I'm sorry, the compiler is going to try to find the constructor is not going to find it. So basically, you cannot create an object of this kind. Even if you define your own default constructor, such as this here, and you say that it does nothing, then the compiler will say that you must initialize these two members inside of your constructor. Okay. So you don't have, if you have members that must be initialized, you must initialize them in the default constructor, or at least in one of your constructors. So this is just one of the subtleties. There's many different subtleties about constructors, such as this one here. You have to be very careful. There's going to be weird things that happen if you use special kinds of members, such as those here, that must be initialized. I'm not claiming here I'm covering all these subtleties. You have to expect that, you know, constructors are going to create some problems if you're trying to use special kinds of features of C++. Okay. So I have explained in what order the constructors are to be called by the runtime system. Now, what about the destructors? So I created here an extended version of the example I gave before, which is essentially the same inheritance chain here, or hierarchy or graph. So basically, G inherits from B and C. C does not inherit from anything. B inherits from A, and A does not inherit from anything. So what I did here is basically I instrumentalized my constructor and destructor. So I declare them explicitly, and all that they do is to print out that they've been executed. Okay. That allows me, when I, for example, I create an object of type A, that it's going to call the constructor of A here when I declare this here. And then when the constructor is called, it's going to print out this here, allowing me to see that this constructor has been called. I do this kind of example very often, as you will see in the course. So for example, when I create an A, then the A constructor is getting called. If you create a B, then you see that the B constructor will first, because here is the trace, when you create a B, what it does is that before this is executed, it will call the constructor of the initial in the base class list of the class B, which is A. So it's going to try to create an A. Now, A does not inherit from anything, doesn't have any members, so it's going to resolve the constructor of A, which is traced here. Then after this is done, there's not anymore in the list here. There's no data members. So now B will resolve, such as this here. So if I create a C, then there's no superclass. So there's no base class, but there is a data member of type A. So A is called, then C is resolved. If you create a G, then it does the same chain of creation as I explained before, okay, in the previous example. It's basically going to go, you call G here, it creates a B, which creates an A. A doesn't have superclass, doesn't have data members. A resolves. Then B, there's no other inheritance here. There's no member, so B resolves. So it goes back here. C doesn't have any base classes. Then A is called, and then C is resolved. And then when you go back here, there's no other class here from inherited from. So that's the end of the list here of inheritance. Then it goes to the list of members. So A is resolved, then, only then G is resolved. Okay. That's the same thing I explained before. The point of this particular example, aside from going into more details with the explicit constructors here and the trace, is to show that when you delete these objects, because when this main function goes out of scope, all of these A, B, C, and G would actually be destroyed, okay? Now that raises the question is, the destructors are going to be called, in what order are they going to be called? Destructors, as a rule, it's pretty simple. They are called in the exact inverse order as the constructors have been called. So for example, when you go out of scope here, then G will be destroyed, then C will be destroyed, then B will be destroyed, then A will be destroyed. If you destroy G, you see as you constructed G, you went A, B, A, C, A, G. You see that when it destroys the G, it goes in the exact inverse order, G, A, C, A, B. And then when it destroys the C, it goes C, A. And then when it destroys the B, it goes B, A. And then when it destroys the A, it goes A. Okay, so the call chain for the destructors is exactly the inverse chain as for the constructors. So that's the end of this lecture. Next thing we'll cover inheritance. Thank you.